It is time to finish up Unit 7. Once again, it is a short unit. I understand that, but there's a lot of information and a lot of work that we've been doing. And this lesson is about putting it all together so that I can show multiple representation of these relationships, these algebraic expressions that we have been doing. So when I look at what we're being asked to do, I know my objective, my goal for this lesson is to be able to identify my dependent and independent variables in any given scenario, in any given situation that I have. And then from that, be able to create my equations, create my table of my independent versus my dependent with my input and my output, and then to be able to graph them. On the introductory page, then on page 423, they give us how we can see these relationships in math. We can do it in words, the equation, create the table, graph it. We can go from one to the other three and be able to work with our information. So let's look at the first example that we're talking about. Once again, we just want to mark it up and we want to figure out what the information is so that I can go through it. So I'm going to go through the first two steps and then we'll carry it over into steps 3 and 4. But I want to start with the example that they give us, which is the student council has already earned $150 this year. For the next fundraiser, they are holding a car wash and charging $7 for each car that they wash. Tells us to represent the relationship between the number of cars washed, C, and the total earnings, T, with an equation, a table, and a graph. So when I see that we've already earned $150 and I'm charging $7 for each and every car that I wash, and I have to determine then which is my independent and which is my dependent. So once again, my independent is going to be the one that I do my work with. My dependent is going to be my answer. So when I see that my number of cars is what I'm doing the work with, that's going to be my independent, to where my total earnings, total meaning equal, that's my answer, that's my output, that has to be my dependent variable. So when I start looking at it, the information that's given, I know that I'm starting with $150. Once I have that $150, it's already set aside, then I figure out how much I'm going to earn during this next fundraiser. And as I do it, I know I'm going to take $7 per car. And in that situation, once again, that's a unit rate, 7 over 1. So I would multiply each and every car that I wash by 7. So I end up, first step, coming up with my equation that T, my total, my output, my dependent variable, is equal to 7C, that's multiplication, plus 150. If I know that that is my equation, then I can take every single step and figure out what my T is going to be equal to, or what my total is going to be equal to for each and every car that I wash. So I'm going to plug in my dependent variable, once again, that's in the purple, for my cars, and I'm going to figure out how much I'm going to make if I wash just one car. So if I have T is equal to 7C plus 150, then that tells me to create the math problem showing my work that T is equal to 7 times 1 plus 150. Now notice that the reds, those are my constants. That's the work that I have to be doing. I have a multiplication and I have an addition. So this is a two-step equation. So I start with multiplication and division from left to right. I do my 7 times 1, which is 7. Then I'm left with my addition. So I know that if I wash one car only, that in the end I'm going to have $157. Well, what if I wash two cars? So I plug that into my equation, and now I have T is equal to 7 times 2 plus 150. Once again, I do multiplication and division before I do addition and subtraction. So I'm going to take 7 times 2. That's going to give me 14. I add my original 150, and I end up that T, my total, if I only get to wash two cars, is going to be $164. I do the same thing with 3. I'm going to plug in my number 3 for my independent variable. I'm going to do my multiplication. 7 times 3 is 21. I add that original 150 that I had already made from my first fundraiser, and I end up with, if I wash 3 cars, I get $171. I do the same thing with 4, and I'm going to do the same thing with 5. So I plug in the 4 for my independent variable, multiplication first, so 7 times 4 is 28. I'm going to then add my 150, and that tells me if I wash 4 cars, I will have $178 when I'm done. And last but not least, then we're going to do the 5. We're going to have that I have 7 times 5, which is 35, and then I'm going to add the 150, and that tells me that if I wash 5 cars, I'm going to have $185. So with that information, with my chart that I have created for each independent variable, what the dependent variable or the outcome is going to be, then my next step is to take my independent and dependent chart and create ordered pairs because I need to graph it. Well, once again, if I have created my chart from my information to where I have my independent on the left and my dependent, my output, my answer on the right, it makes my ordered pairs much easier because my independent will be on the left, which is where my X needs to be, and my dependent is going to be on the right where my Y needs to be. So I just take those numbers and I create my ordered pairs. Remember, every ordered pair must be inside of parentheses and separated by a comma. So I put down my ordered pair from my chart, and then I have to graph them on the coordinate plane. Remember, when it comes to graphing on a coordinate plane, these are pretty easy because once again, we are in quadrant 1, which are all positive, positive. So I know my running's always going to go forward, my jumping's always going to go up. Remember that the order is to run and then jump. So with 157, I'm going to start at 0. Remember that little squiggly line between 0 and the 125 simply means that that covers all of those numbers that we don't end up using. So that's why there's such a big jump. So we're going to start at 0 and we're going to run forward to the 1. And then my Y tells me I'm going to jump up to 157. Now, once again, these are not exact tick marks to show us each and every number that we could end up with. So we're just going to put a point approximately where we think 157 would be. It should just be logical. Should be closer to 155 than it should be to 160. All right, so now I look at my second ordered pair where the 2 is. So I'm going to run forward to the 2, and it tells me to jump up to 164. So an approximate point would go right there, right below the 165. My third point says 3 and 171. So once again, I always start at 0. I'm going to run forward to the 3. I'm going to jump up to 171, right above the 170. My fourth one gives me 4 and 178. So I'm going to start at 0, run forward to the 4, jump up to 178, and put my point. And then my last one that I did is 5 and 185. So I start at 0, I run forward to the 5, I jump up to 185, and I put my point. Now, graphing a relationship means not only do I put the points, but then I draw a line, actually a ray, right? So we have an endpoint at the beginning, and then the arrow at the end of the line, that's what makes it a ray, tells me that those numbers would continue in that pattern if I continue to wash more and more cars. Make sense? Putting it all together? So hopefully this is making sense. We're going to do one more, and then this lesson is yours. Now this story problem gives us a perfect example to show us that everyone makes mistakes because these people get paid big bucks to make these math problems, and it is not grammatically correct. It should say an online store, not an online stores sells. So an online store sells trail mix for $2.75 per pound and charges a shipping fee of $4. Represent the relationship between the pounds of the trail mix bought, which is P, and the total cost C with an equation, a table, and a graph. So we're going to cube it, right? So I know this is information that I need, $2.75 per pound. The word per mathematically in this equation tells me that I have a unit rate that for every 1 pound I spend $2.75. So I know in this problem it's going to be multiplication. They say they also charge a fee of $4. Now, we don't necessarily think of charging, the word charge, as being a mathematical term, but it is included in the mathematical terms when we're doing these type of problems. Because if I'm being charged a certain amount, then I know I have to add that amount in my math problem. And then it says or that we have pounds of trail mix, which is going to be represented by a P. So that's going to be my independent variable. That's what's on the left. That's the one I'm going to do the math with. And then I'm told that I have total cost. And once again, the word total means equal. And I therefore know that that is my dependent. That is my output. That's going to be on the right. So now I have to think about my equation. So in my equation, I know that I'm going to have C, my output, my answer, is going to be equal to math done with the P, the pounds, that I'm buying of the trail mix. And then I have to look at what math is being done, right? So it says 275 per pound. So I'm going to put my 275 in front of the P. Now, just a quick review, always keep this in mind ever since we've been doing algebra, because this is going to be used from this point forward in your life anytime you do math. So that is 2.75p, which is a coefficient touching a variable. And if I have a coefficient touching a variable, once again, that always means multiplication. Just keep that in mind. So then I have to remember that when I look back at my QB, then I see that I have two math symbols there. So that reminds me that I have to also add the $4 fee at the end. Once again, I do multiplication and division from left to right, and then I do addition and subtraction. So when I plug in my independent variables, the 1 through 5, I'm going to do the math of multiplication, then I'll add the $4. So we start with the numbers that are given in my independent column. So I'm going to take 275 times 1, which is 2.75. I'm going to add 4 to it. Now keep in mind that if I'm stacking those on my paper to show my work, and I have 2.75, that would be 4.00 added together. Right? I'm only going to add the whole numbers together and leave that 0.75 alone. So that would give me 6.75, or $6.75 for my total cost if I buy 1 pound of trail mix. All right, so I look at 2 pounds, plug in my information. So once again, the reds are my constants, the math that has to be done. My purple is my independent, my number that's going to change. My C will therefore be my answer once I do the math. I multiply 2.75 times 2. Well, 2.75 times 2 is going to be $5.50. Then I have to add the 4 to it. That would, once again, be the same as adding 4.00, or I simply add the whole numbers and I leave those decimals alone. And I have 5 plus 4, which is 9, so I have $9.50. So if I order 2 pounds of trail mix, I know it's going to cost me $9.50. I continue the pattern. I take my equation, I plug in my 3, which is my next independent number. I do my multiplication. 3 groups of $2.75 gives me $8.25. I add my whole numbers and leave my change alone. So 8 plus 4 gives me 12 with the 25 cents left over. So 3 pounds cost me $12.25. I do the 4, I plug in the 4 for my independent variable. 4 groups of $2.75 gives me $11. When I add $11 to $4, then I have 15. So for 4 pounds of trail mix, I end up spending $15. And then the last one that we're going to plot is going to be 5. So I plug in my independent variable of 5. 5 groups of $2.75 each gives me $13.75. I add the $4 to it. Once again, if I stack 13.75 with the 4, I have to put 4.00, bring down my decimals, and I see that that 75 stays the same. And then 13 plus 4 gives me 1775. Then I have to come up with my ordered pairs. Now, if I have my chart once again set up, on the left are my independent variables, on the right are my dependent, then that makes it easy to come up with my ordered pairs. I have them in the order of P and C, or independent followed by dependent, which tells me that that's going to be the order of my X and Y. So I create my ordered pairs from the chart. Once again, every ordered pair must be in parentheses, separated by commas, and yes, I expect to see these charts on your paper to show your work. I end up with all of my ordered pairs for all 5, and then I'm going to plot them once again, starting in the bottom left at 0, and I'm going to run and then jump. So from 1 over to 1 and then up to 6.75. Once again, these are not exact tick marks, so it's just going to be, as close as I can get to the 6.75. I'm going to run forward to 2 and jump up to 950. Run forward to 3, jump up to 1225. Run forward to 4, jump up to 15. And then run forward to 5 and jump up to 1775. Finally, if I graph a relationship once again, then I use an array or an arrow to show that those numbers will continue on as long as I continue to buy more and more of the trail mix. All right, so that's it. That's putting it all together. It's a short video, the shortest one of the entire lesson, but there's a lot of work to do with each of these problems. You have 5 questions to do for your homework. Take the time to do your best and ask questions. Review this video as many times as you need to.